So all of the functions that we just looked at were exponential functions. How do I know that it's an exponential function? What did they all have in common? The x was the exponent, okay? The variable was the exponent. So an exponential function is going to have a variable that's the exponent, all right? So they were all similar. Did they all have a similar shape? Yeah, every single one of them, okay? And they're all going to have that similar shape, whether or not they're transformed up or down along that x-axis or right to left along the y. I'm sorry, scratch that, reverse it, okay? Translated up and down along the y, translated right to left along the x, okay? They're all still going to have that general shape. All right, so you should be able to visually see an exponential function and know it's an exponential function. All right, all right, so your basic exponential functions are going to be of the form y equals b to the x. B being what we call our base. B stands for base, okay? And then x being your exponent. All right, we already did our station, so let's move on to the next question. Okay, so based on the functions that we just graphed, let's talk about what the domain and the range for these exponential functions are. So let's talk about domain first, all right? Looking back at our station, here's all of our functions, right? What's domain? X. What x values are being used? All of them. Good. Give me a mathematical way to say all of them. More than that, please. Negative infinity to positive infinity. Great. So my domain is going to be, we could say all real numbers, or we could say negative infinity to positive infinity. We're going to write in interval notation, negative infinity to positive infinity. Okay, so that's our domain. There is an infinity symbol in your pi key, which is down here next to the H. Okay. Okay, so there's domain. What about range? Yeah, my y values. What kind of y values am I using? It definitely depends on the graph, but for the majority of them, if we're just talking about b to the x, right? Things that look like this, what values of y are being used? The positives, great. Give me a little bit more. How would I state that in interval notation? Okay, great. Nice job, Gia. 0 to positive infinity, but am I using 0? No, I'm not. So what did you notice about all of these functions? What happened to my graph as I moved to the left, to the negative x? It got smaller and smaller and smaller and smaller, but did it ever hit 0? Would it ever hit 0? No, it wouldn't. Am I going to include 0? No. Am I going to include everything greater than 0? Yeah. So we're going to open bracket, okay? Open. So we're not going to include 0, but we're going to include everything that's a little bit bigger than 0, everything from 0 to a positive infinity. Do we know what that's called, what that actually gives us? We're saying that our function can never equal 0, right? So it's approaching the x-axis, but it never actually touches it. What is that called? We have a special word for it. It starts with an A. Thank you. He was saying it to you, and you just looked at me. Yes, good, Tyler. Asymptote. Okay? Okay, so it's what we call an asymptote. So an asymptote is like a magical line that a function can never touch. So it's getting closer and closer to what? 0. Y equals 0, right? Y equals 0 is what we call our horizontal asymptote. Okay? It's never going to equal it. So it's our asymptote. It gets closer. We call it arbitrarily close. It gets closer and closer and closer and closer and closer, but it never actually becomes it. Okay? Have you guys heard that word before? You have heard the word before. You may not remember it, but you have. Okay? Asymptote. Okay? Asymptote. So our asymptote is y equals 0. Okay? Is it always going to be y equals 0? No, not always. When we have functions that look like this, that y equals b to the x, it's always going to be y equals 0. But then when we start transforming them, when we start moving them along that x and y axis, that's when our asymptotes are going to change a bit. Okay? Can I move on? Okay, so we had our domain, negative infinity to positive infinity, and our range from 0 to infinity. Good? Okay, for functions of this type, our domain is always going to be negative infinity to positive infinity. Are you okay with that? All exponential functions in general are always going to have a domain of negative infinity to positive infinity. You okay with that? Every single one of them. Got it? Okay. Okay, next page. All right, so oh no, don't look. Can you see it on me? Don't look anyways. Which one of these functions is going to be increasing? Oh, you cheaters. Why is it 2? Say it again, John. It's bigger than 1. Okay, the base is bigger than 1. In order for an exponential function to be increasing, that base has to be larger than 1. Is 5/4 larger than 1? Absolutely. Okay, good. Next page, please. All right, so let's consider the function 7 times 3 raised to the x. This one's a little bit different, right? What's new? Yeah, that 7's there. Can I just multiply the 7 and the 3? No, not unless you want me to stomp on your foot. Okay? No, you cannot multiply them, all right? So this is actually going to do something interesting to our graph. So we're going to take and we're going to find the y-intercept algebraically. Okay? So let's talk about y-intercepts. All of our functions had the same y-intercept that we just dealt with, right? What were all of the y-intercepts? Look at that lab. Where did every single one of those functions, except for the negative 2 to the x, cross that y-axis? I need a point, not 0, 1. Okay, the y-intercept for every single one of them was 0, 1. Why? Anything to the 0 power is 1. Very good. Okay, is that going to be the case here? Why not? Good. Okay, so how would I do this algebraically? Raise 3 to what power? 0. Why 0? Yeah, if I'm talking about the y-intercept, we're saying every single one of them was the point 0, 1, right? That's because at x equals 0, I'm going to have a y-intercept. Agreed? So to do this algebraically, we're going to take and we're going to plug in 0 for x. Okay? 9th grade, guys. X and y-intercepts. Find the x-intercept, I plug in 0 for y. To find the y-intercept, I plug in the 0 for x. Okay? Now what? Good. 3 to the 0 power is 1. Great. Y equals 7. Now, what's the y-intercept? 0, 7. Excellent. So, how did this graph change? It moved the y-intercept. Did it change? Did it move the entire function? No, it's not a vertical shift. Okay? So it did change it. It did change the y-intercept. So that's going to happen each and every time. Are we okay so far? Okay. Let's move on to the next one. All right, does the exponential function increase or decrease? Explain your choice. So again, it was y equals 7 times 3 to the x. Is it increasing or decreasing? Increasing. Why? What's the base? The base is greater than 1. Okay, the base is greater than 1. Great. Are we okay? All right, so we're going to create a rough sketch. You're going to do this in your notebook. I want you to create a rough sketch of this function. I don't want you to graph it in your calculator. I want you to take the information that you just gathered. You know it's increasing. You know the y-intercept, okay? I want you to do a rough sketch of this function. Make sure you label its y-intercept. Okay, so let's see. We should have something that looks with a value here at 0, 7, right? It's probably going to look something like this. How many of you had something that looked like that? Yeah, it's increasing on the interval from negative infinity to positive infinity. It has a y-intercept at 0, 7. Okay, good. Any questions about that? Next page. All right, so let's look at something a little bit different. I've got 1/3 raised to the x plus 4. Okay, what's happening to this function here? I'm adding 4. What does that do? What am I adding 4 to? Yeah, I'm adding it to the 1/3 raised to the x. Okay, so where is that going to move it? Up. How many units? 4. Okay, so when we think about taking something and moving it up 4, we talked about asymptotes before, right? What's going to happen to my asymptote? It's going to move up 4. Okay, so everything is going to get shifted up 4 units. Good. So this is a vertical translation of 4 units up. Okay, vertical translation of 4 units up. How would I find the y-intercept? Good. Do it. What are you going to get? 5, so 0, 5, right? You guys okay with that? All right. So real quick, and then I got to move on to something different. What was it, 1/3 raised to the x plus 4? There it is. Where's your asymptote? Y equals 4. Okay. All right. I'm going to send you your quick quiz. It's going to be at the end of the day today because we started a new unit. So that's going to be sent to you in just a moment. So we're going to go ahead and get that started. I did send you a new weekly project project 8. Okay. That is in your handheld already. That's going to be due Friday. You don't have homework tonight. So your homework is to work on that weekly project 8. It's only 10 questions. You should be able to finish it tonight. Okay. So go ahead and get that quick quiz done, and I'll collect it from you before you leave.